Hello everyone, and welcome to another part of the Unity scripting tutorial videos. In this video I wanted to make another terrain video and another procedural terrain, and for this one I want to use Perlin-Noise instead of the diamond square algorithm. So if you've already seen the diamond square algorithm, a lot of this video will look familiar because for the most part creating the terrain and all that stuff will be the same. The only difference between the two methods is the height of each vertex. So the first thing that we're going to need, just like the other video, is an empty game object. Let's zero out the position and then add a mesh filter as well as a mesh renderer. And then attach a material to it. And now that we have everything set up, we can create our Perlin-Noise terrain script. So create C# script Perlin-Noise terrain, and attach our script to the game object. So there we go. Now we can open up the script and get started on it. So just like our diamond square terrain, what we're going to have is the divisions, size, and height. So we'll go ahead over here and create our public int mDivisions. I should probably make this a bit bigger. There we go. So we have public int mDivisions, public float mSize, and public float mHeight. And mHeight is the maximum height for the terrain. The size of the terrain is going to be the size in the world, how big it is, and the divisions is how many faces it's split into. Now to move on, we can create our void create terrain function. So void create terrain, and in here we will do a lot of the same thing that we did in our create terrain function in the diamond square algorithm video. So the first thing that we'll need is the arrays that we're going to pass into our mesh. So vertex array, UVs array, and a triangle array. So what we can do is create a vector3 verts vector2 UVs and an int tries. Of course, these are arrays, so vector3 array and vector2 array. Now we also need our vertex count. So what we can do is say int vert count is going to be equal to, and for the vertex count, since our so let's say that we have our divisions being 2. So if we have 2, that means that we have 1, 2 by 1, and 2. And this is what our terrain would look like. So the number of vertices that we need is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's whatever the divisions are plus 1 multiplied by whatever the divisions are plus 1. So what we can do is, first let's make another int. Let's call this one div plus 1. So plus 1 is going to be equal to undivisions plus 1, because we're going to be using this quite a bit. And our vertex count is going to be equal to div plus 1 multiplied by div plus 1. So for vertices is going to be a new vector3 of size vert count. Our UVs are going to be the same idea, new vector2 of size vert count. And finally, the triangles that we have are going to be, so the number of triangles is going to be our how many vertices that we have, because let me see here, back here again. For each one of these verts, we are going to draw a face, and each face is made out of 2 triangles. But we only need faces that are pretty much, so for example, if we have 2 divisions, we only need 2 faces multiplied by 2 triangles. So the number of triangles that we're going to have is going to be equal to the number of faces that we have, which is m divisions, so new int array of m divisions multiplied by m divisions, because the number of faces is going to be 1, 2, 3, 4, and our divisions is 2, so it's 2 times 2 faces. And each face is made out of 2 triangles, so it's going to be m divisions times 2. But in Unity, each triangle is described by 3 values. So this is going to be times 2 times 3, or just times 6. And this is the number of triangles that we will need. Next up, we're going to have a few helper variables, which will be float half size is going to be equal to m size multiplied by 0.5f. Float division size is going to be equal to, so a division, one of these, is the whole size divided by how many divisions we have. So it's going to be equal to m size divided by m divisions. Now we need to get our mesh from the mesh, or create a new mesh and add it to our mesh filter, because over here in Unity we attached a mesh filter to our object. Now right now it has none, so we need to get this mesh and give it a value. So we'll make a mesh equals a new mesh, and we'll say that get component mesh filter dot mesh is going to be equal to our new mesh that we have here. And then the last variable that we need before our loops is the triangle offset. So int try offset, and we'll use this equals 0. We'll use this to set up our triangles later on. So what we need to do is loop through all the verts of our terrain to create them. So we'll need 2 for loops. First one, int I equals 0. I is less than m divisions, but divisions is less than vertices minus 1. So we need to go all the way to 3, or 0, 1, and 2. So we need to go less than or equal to the divisions. So I is less than or equal to the divisions, and then I plus plus. Now we'll do the same thing for j. So for int, oh, I didn't put I there, int I, int j equals 0, j is less than or equal to m divisions, and then, why do I have int plus plus? Wow. So I plus plus and then j plus plus. And this will loop through every vertex that we need to go through. So now let's create the verts. For now we're going to create a flat terrain and then add the Perlin-Noise height afterwards. So we'll say that our verts at, this is going to be I multiplied by the divisions plus 1 plus j, because I is our rows and j is going to be our columns. So this is so that because we're representing the vertices, the verts are in a one-dimensional array and we're trying to describe a two-dimensional matrix. So we have it set up this way to get our current index. And this will be equal to a new vector 3. For the x, it's going to be negative half size plus j multiplied by our division size, because we're starting from the negative x and going this way, and we're going by j, which is our columns. For the height, we'll keep it at 0.0f, and for the z, we're going to start at positive z and go backwards onto the negative. So it would be half size minus I multiplied by the division size. And this will be it for our vertex positions. Now for our UVs, at I times division plus 1 plus j is going to be equal to a new vector 2. And this vector 2 will take in a float of j divided by the m divisions and a float of I divided by m divisions. And all this would do is just take a single texture and spread it across the entire terrain. And now the final thing that we need to do is create our triangles. Of course, we don't need an update function for this class because nothing is going to be updated, so we can just erase that. Now for the triangles, and the triangles are going to be at each vertex that's not the last vertex in the row and column. So if we're here, we need to create a triangle here and a triangle there. But if we're here, we don't need to create anything because there's nothing to create here. So we need to say that if I is less than m divisions and j is less than m divisions, so if either one of them is less than m divisions, if both of them are less than m divisions, because if j is at the last one, we don't want to create anything, and if I is at the last one, we don't want to create anything. So we have that. We need to create the triangles, and for the triangles, we need the index of the top left and the bottom left vertices. So the top left is going to be the same as our vertex right here. So we'll say int top left is going to be equal to I multiplied by the division plus 1 plus j, and int bottom left is going to be equal to I plus 1, because I is the rows, and if we want this one, we just go down one row. So I plus 1 multiplied by the division plus 1 plus j. So that would give us top left and bottom left vertices. And with that, we can create our triangle. So the triangle is going to be, the first triangle is going to be top left going to top right, and then going down to the bottom right. So this will be our first triangle. So tries at triangle offset is going to be equal to our top left. Tries at try offset plus 1 is going to be equal to, so top right, which is our top left plus 1. So top left plus 1. And then tries at try offset plus 2 is going to be equal to our bottom right, which is our bottom left plus 1. So bot left plus 1. So now for the second triangle, which is going to be top left down to bottom right back to bottom left. So tries at try offset plus 3 is going to be equal to top left. Tries at try offset plus 4 is going to be equal to our, so we're going down to the bottom right, which is the bottom left plus 1, bot left plus 1, and tries at try offset plus 5 is going to be equal to our bottom left. And this will create all our triangles. The last thing we need to do is to offset the try offset by 6 to get ready for the next phase. So try offset plus equals 6. And this will be it for the 3 arrays that we have. Now the last thing we need to do is to assign these to the mesh and then see what it looks like. We should have, by the end of this, just a flat terrain, because we haven't edited the height yet, we just have it at 0. So mesh dot vertices is going to be equal to verts. Mesh dot UVs, or UV is going to be equal to UVs, and mesh dot triangles is going to be equal to tries. Now we do need to do mesh dot recalculate bounds and mesh dot recalculate normals. And we can go ahead and test this to make sure that we are creating the terrain. So in start, we can say create terrain, so that the terrain is created as soon as we run the our level. So now we have our object, we have the terrain here. The divisions, let's say it's something like 128. The size, let's give it a size of 10, and let's say a height of 1. We're not using the height now, but let's just set the height to 1 for now, and then let's run it and see what we get. And there we go. So now we have just one triangle, one terrain made out of 128 by 128 faces. So this seems to be working pretty well. Now we can move on to our Perlin-Noise function. So in here, when we're recalculating, when we're assigning the height right before it, we can calculate our height. And for that, we will need a couple of variables. So we have float x coordinate, which is going to be equal to float of I, or j, actually j divided by m divisions, and this will give us a value between 0 and 1, because j is between 0 and m divisions. Next up, a float y coordinate, so y coord is going to be a float of I divided by m divisions. So we have here j divided by m divisions. And then the last thing that we need to do is to calculate the height. So to start off, we are going to be using the Mathf.PerlinNoise throughout this, but to start off, let's just use these heights. So we'll say float height is going to be equal to Mathf, so Mathf.PerlinNoise at, so our x coordinate and our y coordinate. By the way, if you're wondering why, oh, this should be I. If you're wondering why this is j and this is I, is because our x is our columns and this is our j. Our y, which is our z in this case, is our i's, which are the rows. So this is x and y. And now we can just assign the height to the y value of the terrain and see what that looks like. So if we can go here and run. So there we go. It seems like it's curving a little bit, but since it's going from 0 to 1, it's not really spreading out too much. So we probably need to make these values a bit smaller. So, or a bit bigger actually. So the x coordinate and the y coordinate need to be spread out a little bit. So for that, we will take it and multiply it by 4 times 4. And that should give us a bigger portion of the Perlin-Noise map that's in Unity. And there we go. So now we have a very uniform terrain. And this is, well, this could be good enough if you're making like some sort of desert map or something, but sometimes you want a bit more definition for it. And to do that, we need to accumulate multiple Perlin noises with different aspects into each other. So to do this, we have here Perlin noise of x coordinate multiplied by 4 and y coordinate times 4. Oh, the last thing that we forgot to do is take the height. So height times equals our m height, so that we can set our max height, because the Perlin noise returns a value between 0 and 1, so we multiplied by the height to raise everything. So if we go back to Unity and run this, so the height right now is equal to 1. So if we raise the height to, let's say, 2, everything should be a bit higher. There we go. But it's still way too uniform, so we need to add a bit more detail into it. And to do this, we are going to add a 0.5 f multiplied by a Mathf.PerlinNoise, so another Perlin noise, but this time around we are going to lower the detail a bit. So to increase the detail, we multiplied by 4. So what we're going, or to increase the detail, we multiplied by 4, and we need to add more detail, even more detail in a smaller section. So what we're going to do is to multiply it by something higher. So let's say 8. So we can do x coordinates multiplied by 8, for example, and y coordinates multiplied by 8. So now that we have this, we can go ahead and run it again. And there we go. As you can see, there's a bit more detail. And we can do this another time. So we have 0.5, so we can go to 0.5 and 16 on top of that. So plus 0.25f multiplied by Perlin noise. So Mathf.PerlinNoise. And in here, we'll do x coordinates multiplied by 16 and y coordinates multiplied by 16. And then now we can go back to Unity and run this one more time. And there we go. So now we ended up with a terrain with a lot more detail than we had before. Now we might want to increase or decrease like the values of like, for example, if we want the high mountains to be really high and the hills to be more flat, we can take the power of that. So we can do height is equal to Mathf.power of, let's say, of height to the power of, let's say, something like 2. And with that, we can run it again. And there you go. So the valleys are more flat, and the hills are a bit higher than they were than before. If we increase the power to something like 10, for example, and run this, as you can see, it's very flat here, but this is very high. And you can just play around with these values to generate the kind of terrain that you want to generate. But yeah, this is pretty much the whole idea behind it. If I make the terrain a bit bigger, maybe that'll, so maybe spread it out over 100, for example. So there we go. So you have a more flat terrain with more defined hills and mountains and so on. So, but yeah, this should be it for this video though. I really hope that this video helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.